Hello friend, myself Sanjeev Dwivedi on behalf of Vidyalankar Institute of Technology. I welcome you all in this Java session. In this session, we are going to talk about abstract method and abstract class. Now, what is abstract method per se first? Uh, Let me take an example and we'll understand it better in this way. Now, suppose I'm having a class. Suppose I'm having a class and let the name of the class be shape. And let's say class shape has a function. The function is void display area. Now the point here is in display area function, I wish to write a code to display the area, particular area. Now the point is if it is circle, if it is rectangle, if it is cone, then cylinder, then we can write a formula for displaying the area. The point here is shape is not a fixed particular geometric shape. So when it comes to displaying, writing a code to display the area, we are not sure what to write. You're not sure what to write. So now the point here is ki, what I want is ki, suppose I've written anything here, anything, and this is my class. Okay, and there is another function void f1 which says sop f1 of shape. See, so we have consider the senior. We have a class shape. Class shape has a display area function, but we are not sure what kind of code we are supposed to write in display area function. So I'm just keeping it side, and it contains another method f1. Now there is a compulsion. Suppose I impose a compulsion कि any geometric figure, let's say if it is class circle, now circle is a geometric figure, any geometric figure, if it wants to display its area, it has to use display area function of shape class. Now suppose I make this kind of compulsion. Any geometric figure, if it's supposed to display the area, must use display area method of shape class. Now if that class circle intends to use display area method of shape class, then it must extends shape class. And now suppose it has double r radius, and now suppose it has constructor circle double r1, so r equals to r1, and now it overrides display area method void display area, and it says sop area of circle is 3.14 into r into r. Now here writing display area function like this makes sense because since it is a circle, it will have a formula. If it is a rectangle, we could have specified length into breadth. But writing giving body to the function here doesn't make sense. So what kind of scene we have? Now suppose there is a scenario where there is a base class. There is a base class or super class, we'll say shape. It has a certain method display area. The method does not have any body or does not make any sense in its own class, but it makes sense in derived class. So ideally speaking, what we should do is we should remove body given to this method here. We should remove body given to this method here. And now we have a display area method that does not have any body. So we will declare this, we will declare it as abstract. So what is an abstract method? An abstract method is a method of a class that does not have any body in it in that particular class. So display area does not have any code, does not have any definition in shape class. It has only declaration. So a class that has a function that does not have any body, or a class that has a function which is abstract, such class is also declared as abstract. Now what do you mean that? Now class shape has one abstract method. So it goes like this. If a class has at least one abstract method, then the class is declared as abstract. So what we have here is class shape has an abstract method display area and a non-abstract method f1. Now, since class circle extends shape, the circle will have both the version of the function. Now, circle class has to override the abstract method display area. If it doesn't do so, then circle class will also have a blank copy only declaration for the method display area. So circle class has to be declared it as abstract. See, if a class has at least one abstract method, it must be declared as abstract. What we have is class circle extending an abstract class shape. Shape is an abstract, will have at least one abstract method. So it is, we are overriding here and we have given the body to display area. See, class circle has not given any new body to F1 function, but still the F1 function is there in circle class. So if I create circle object, something like this, circle C1 equal to new circle, and I said 5 passed as a radius, and if I say C1 dot display area, so it will call this display area giving the area of the circle. I can also call C1 dot F1. Now it will call F1 method of shape class that circle class inherited. How do we conclude? If a class has a method that does not have any sense in its own class, but meant to be redefined in derived class, such methods in the class are declared as abstract. If a class has at least one abstract method, the class becomes abstract. Now the point is, shape class is an abstract class that has one abstract method display area, another non-abstract method F1. Class circle extends shape, so it must override display area. If not, then circle has to be declared as abstract, but it may or may not write F1. So if a method is abstract, it is kind of mandatory for it to be overridden in derived class. It is kind of mandatory for it to be overridden in derived class. So display abstract methods are meant to be overridden in derived class. Let's see. Abstract is a modifier used with method or a class. Abstract method is a method that is declared without any implementation. It will not have any body. The implementation is to be done in subclass, making overriding compulsory. If we do not do so, then even the subclass will become abstract. It is opposite of final, because if a method is declared as final, it cannot be overridden in derived class. But here, if a method is declared as abstract, it must be overridden in derived class. If a class includes abstract method, then the class itself must be declared as abstract. That's what we said. Now, when an abstract class is subclass, the subclass usually provide implementation for all the method. Now, this is very interesting. Now, I'm saying all the method. See, all the abstract method specifically. See, here we have abstract class shape, variable 1, variable 2. Method 1 is having some body. Method 2 is not having body. It is declared as abstract. Now, if a class circle extends shape, if it does not implement method 1, it is okay, because method 1 is already having some body, but it must override method 2. It must override method 2. Now, there is a point. Now consider, now why I'm saying all the methods. Now suppose if a class has A, and if it has abstract void F1, abstract void F2, and the class is abstract. So here we have an abstract class where both the methods are abstract. So if we have any class B that extends A, so these two blank methods are now present in B. So B has to override both. B has to give body to both. Now, void F1. Suppose if B gives body to only F1 and not F2, then B has to be declared as abstract, because class B still has abstract method F2. Now, to avoid that, what we have is, we'll say void F2. So this is what I mean by saying, if a class inherits an abstract class, it must override all its abstract method. Now, suppose class A contains two abstract and it has another method F3 which is not abstract. So class B, it's not mandatory for class B to override the third method. Is this clear? Let's see. Now, the super keyword plays very important role here. Now, what do you mean? Let's see with example. Now, suppose we have class A. Class A has a data member I. And suppose class B extends A. And class B contains same data, recreates the same data member I. Now, class B has two I, one from class A, one from itself. So in class B constructor, I should assign variable to 2i. So A and B, two variables. Now here I want to access I of class A. I want to access I of class A. See, here we have I method. Here I want to, if I simply write I equal to A, then this I will be of class B. I want to access I of class A. So I'll write super dot I. And if for A is assigned to super class I and B is assigned to subclass I. Now, even while displaying, if I say I in superclass, I want to display the I of superclass, I should write super dot I. And if I simply write I in class B, then it is I of class B. So basically, what is super keyword? Super keyword is used to access the superclass members in subclass. The superclass members in subclass. Let us see further detail. Let me take one more example. Now, if you have class A, data member X, there is constructor that initializes data member to 5. There is another constructor int X, P, that initializes to, and there is a function display. That displays value of X. Place. Okay. So here we have class A data member X. We have default constructor that initializes with 5. We have parameterized constructor, and then we have display function. Now suppose if you have class B that extends A, and you have here data member Y. So basically B has two data member X and Y. So in B class constructor, first what you want to initialize value of X. So what you want to call the super class constructor of class, you just write super and bracket, that's it. And here write Y equal to 5. Now in parameterized constructor of class B, you're supposed to pass two data member, P and Q. But using P, I want to call superclass parameterized constructor. I'll pass P to super and Y will be initialized with Q. Even in display function of class B, I wish to call super dot display. It will call display function of class A. And now have a look of the sequence. See, if I write B1 equals to new B, it will call default constructor to B here, B1. B1 will have XY. It will call default constructor of class B, control goes here. Here we call default constructor of class A, control goes here, X is initialized with 5. Controls comes back here, Y is initialized with 5. And then go back here. If I say B2 equals to new B, 1020, it will call parameterized constructor here, super P, control here, X is initialized to 10. Here for B2, X is initialized with 10, Y is initialized with 20, because here. And then if I say B1 dot display, control will go to B ka display, here I call super dot display. So it will call super class ka display. So from derived class display, I'm calling super class display. From derived class default constructor, I'm calling superclass default constructor. From derived class parameterized constructor, I'm calling superclass parameterized constructor. So basically, this is use of super. Let us discuss here. See, whenever subclass is to refer the immediate superclass, it can do so by using super keyword. See, a constructor cannot be inherited, but derived class can call the base class constructor using super and parenthesis. In parenthesis, if you pass parameter, it will call parameterized constructor. If you don't pass parameter, it will call default constructor. See, the first use is to call superclass constructor. I may use super parameter list. It will call the superclass constructor. For default, if you simply write super and blank parenthesis. So from derived class default constructor, it will call superclass default constructor. And if you want to call function, then it is super dot member. Like I said, super dot display or super dot I we were talking about. So these two are uses of super keyword. Super keyword to access superclass members from derived class. This is example. So this is about super keyword, an abstract method and abstract class. For detail, you may refer Hubbard Schild, complete reference. Thank you very much.